This sound, created by electronic music producer Graphite, once again uses virtual analog sound waves to create a deep sub-bass that's typical of drum and bass or dub bass sounds and many other music genres. It's a fairly basic design, but quite efficient for its purpose. Let's focus first on engine 1. The designer chose to use a wavetable engine to generate the sine wave, probably to leave the possibility to use modulation such as FM, PM, wavefolding, etc. But since they are not used here, we might as well have used a virtual analog engine instead. Anyway, since it uses a sine wave, a filter would have little effect since there are, at least theoretically, no harmonics to filter out. But just to make sure it has no effect, the engine 1's output bypasses the low-pass filter 1. But there are two other things I want to focus on regarding the first engine sound. First, the attack is pretty short, and it gives this interesting percussive stroke at the beginning of the sound, which is what we want with this specific sound style. Now, you might wonder why we can still hear this aggressive attack on the overlapping notes since we are using a legato mode. Well, this is due to our second parameter of interest, which is the use of this function, which drives the pitch of the first engine. By default, it is pretty fast, so you barely hear its effect on the pitch, but it does have an effect on the attack. And because it's triggered by every note, the fast attack is still active even for overlapping notes. Let me say a few words about this behavior. In Pigments, like in many other synthesizers, you can define the number of notes that you can play simultaneously. It's called a polyphony. Usually bass sounds are monophonic, which means you can only play one note at a time. And in that case, you have two choices. You can either retrigger the amplitude envelope on the sound of every note, even when the second note starts before the first one is finished. That's what we call the overlapping notes. Or you just maintain the amplitude level of the first note when the second note starts, what's called a legato mode, because, well, that's how it's called in music theory. So here we're in legato mode, but function 1 is retriggered on every note, and that explains why we still have this percussive attack on every note, overlapping or not. Now, if you slow down this function, then you can clearly hear this glide almost 1 octave long. You can play with this delay to give the sound another style. Now, regarding engine 2, well, it's pretty simple. You use the same setup as for engine 1, except that you start it 1 octave higher and with a slightly lower amplitude. Oh, and also we use filter 1 this time because we can optionally change the waveform from a pure sine wave to triangular, sawtooth, or square waveforms, which all generate higher harmonics. So in order to decide which harmonics, if any, must be filtered, we use filter 1, which can also act as a volume controller. And all these light changes will be emphasized by the use of some effects, as we'll soon see. Finally, the third engine, also called a utility engine, will be merely used to add some noise to the sound by using a white noise sample that will loop forever, with a random phase on each loop if desired. It will be controlled by macro knob 3 here, and it is set to atonal mode, which means that it won't depend on the key played on the keyboard. And of course, here, filter 1 is completely bypassed. Now, all this setting, as said before, will be featured in a more dramatic way by using the effects stage, where it will mainly be the distortion and the multiband compressor that will give this sound its colors and specificities.